Numbers are everywhere. We use them to count objects, measure distances, track time, and so much more. In the vast universe of numbers, two types stand out for their simplicity and importance: whole numbers and natural numbers. These fundamental concepts form the bedrock of arithmetic and serve as essential tools for understanding the world around us. Imagine a basket of apples. You can count the apples, 1, 2, 3, and so on. These counting numbers, starting from 1 and extending infinitely, are known as natural numbers. Now imagine you've eaten all the apples. The basket is empty. To represent this absence of apples, we introduce the concept of zero. Whole numbers encompass all the natural numbers along with zero. In this exploration of numerical concepts, we'll delve deeper into the properties of whole numbers and natural numbers, highlighting their similarities, differences, and the crucial role they play in the realm of mathematics. Whole numbers, as their name suggests, represent complete quantities. They are the numbers we use to count objects in their entirety without fractions or decimals. The sequence of whole numbers begins with 0 and continues infinitely in increments of 1. This set includes 0, 1, 2, 3, 4, and so on, extending towards infinity. Think of a baker arranging cookies on a tray. They might arrange 12 cookies representing a whole number, or they might have an empty tray representing 0 cookies, which is also a whole number. Whole numbers provide a way to express these complete quantities in a clear and concise manner. Whether we're counting the stars in the sky or the grains of sand on a beach, whole numbers provide a framework for quantifying the world around us in its entirety. They form the basis of counting, measuring, and numerous mathematical operations. Natural numbers are the counting numbers we learn from a very young age. They are the positive integers that start from 1 and continue infinitely. The set of natural numbers is represented as 1, 2, 3, 4, 5, and so on, extending towards infinity. Imagine a child counting their toys, starting with 1 and progressing upwards. Each number they use to represent a toy is a natural number. Natural numbers are inherently tied to the act of counting and enumerating objects in our surroundings. From the number of petals on a flower to the number of planets in our solar system, natural numbers provide a fundamental way to quantify and understand the natural world. They form the foundation for counting, ordering, and establishing patterns in our observations. The key distinction between whole numbers and natural numbers lies in the inclusion or exclusion of 0. Whole numbers encompass all natural numbers and the addition of 0. This seemingly small difference has significant implications in mathematical operations and concepts. Consider the concept of having nothing. Natural numbers, focused on counting tangible objects, lack a way to represent this absence. 0, incorporated into the set of whole numbers, provides a numerical representation for nothing, allowing us to express concepts like empty sets, starting points, and neutral positions. Furthermore, 0 introduces unique properties to mathematical operations. Any number added to 0 remains unchanged, and any number multiplied by 0 results in 0. These properties, stemming from the inclusion of 0 in whole numbers, are fundamental to arithmetic and algebraic concepts. A common misconception is that whole numbers and natural numbers are interchangeable terms. While they share many similarities, the inclusion of 0 in whole numbers creates a distinct difference. Understanding this difference is crucial for accurately applying these number systems in mathematical contexts. Another misconception arises from the concept of infinity. Both whole numbers and natural numbers extend infinitely. However, it's important to remember that infinity is not a number itself, but rather a concept representing an unbounded quantity. Both sets are infinite, meaning they have no end, but they differ in their starting point. By clarifying these misconceptions, we can foster a clearer understanding of whole numbers and natural numbers, enabling us to navigate the world of mathematics with greater precision and confidence. Whole numbers and natural numbers are fundamental concepts that underpin our understanding of mathematics. Whole numbers, encompassing 0 and all natural numbers, provide a complete system for counting and representing quantities. Natural numbers, on the other hand, form the building blocks of counting, starting from 1 and extending infinitely. While seemingly simple, these number systems play a vital role in various mathematical operations, concepts, and real-world applications. By grasping the properties, similarities, and differences between whole numbers and natural numbers, we equip ourselves with essential tools for navigating the fascinating world of mathematics and its countless wonders.